Hi everyone, welcome to the first photography technique tutorial of the MIT Museum's Imaging Science program. My name is Brian Murnoff. I am the education coordinator here at the museum, and I'm here to go through some techniques and settings and things that you can use to take advantage of your camera to make some great science photography. The techniques that we're going to talk about will apply to all different types of cameras. So whether you're taking pictures on a cell phone or a point and shoot or a DSLR or mirrorless, we're going to cover techniques that work for all of these that don't require any specialized equipment except for the camera that you have in front of you. So with that, we're going to get started in this tutorial and go over some of the basic settings of your camera and how they work. So to start, cameras today, digital cameras, have the sensor. So what does the sensor do in the camera? The sensor is basically a photon counter. It just tells you how much light is going to enter the camera while you're taking the picture. I mentioned photons. Photons are the way we're going to model light when talking about digital photography. So when we think about light coming from a source or a picture, so let's say I'm going to take a picture of a person here. So here's the person I want to take a picture of, and there's going to be light bouncing off that person. And we're going to imagine that that light is bouncing off that person and coming towards the camera center as these little pieces, little particles of light. When they get to this sensor, the sensor is going to count how many photons hit the sensor in a certain place, and that's going to create our image. So you may have heard of megapixels when looking at different cameras. Different cameras have different numbers of megapixels, and all that number means is how many spots roughly you have on your sensor to measure photons. So how many little places there are. And so if we zoom in on the sensor, you can start seeing what are called photosites that come together to make pixels on this sensor. Now for the techniques that we're going to be using throughout this tutorial series, the only requirement is that you have a camera and that camera can change settings. Those settings are the shutter speed, often represented with a fraction of a second, the ISO, which is a number usually between 100 and 10,000, but it can go on either end of that, and the aperture. Most DSLRs and point and shoots should have this functionality built in. You may have to go to a mode called manual. On a cell phone, some phones have the ability to change these settings just out of the box. Their apps are able to. Sometimes you need to download a different app that will give you access to these settings. The one thing to note about whatever app you use, if you're going to use a cell phone, you cannot adjust aperture on a cell phone. Now that you have the ability to change your camera settings, we're going to talk about what all of these do. And essentially, all of these control how much light enters your camera. The more of those photons, those little pieces of light that reach your sensor, the brighter your image is going to be. And so we have three different ways. This is often called the exposure triangle to adjust this amount of light. We have ISO, aperture, and shutter. And well, why do we have three different ways to do the same thing? Each one has a secondary effect on the image. So they don't just change the brightness of the image, they change something else about the image that we're going to explore. So the first setting we're going to take a dive into is the shutter speed. Now the shutter is a piece of thin material. It's kind of like a vinyl plastic material that can open and close and either let light in or block light from hitting the center of your camera. So let's see how this works. The shutter speed is measured in fractions of a second. So for example, if we had a shutter speed of 1/30, that means that the shutter is open, letting photons into the center for 1/30th of a second. And you can have shutter speeds usually ranging between 30 seconds and 1/8000th of a second on many cameras. And some cameras can go even longer or shorter. The longer the shutter speed, the more photons enter your camera and the brighter your image is going to be. The shorter your shutter speed, the fewer photons are going to enter your camera and the darker the image is going to be. If you're taking a picture with a cell phone, it doesn't have a mechanical shutter. It doesn't have these pieces of plastic that move in front of the sensor. It's too small. And so what a cell phone will do is, in order to take a picture with a cell phone, you need to be able to see the image before you take it. There's a live feed. You can see the light coming in to the camera. But in order for you to see a live picture before you take the picture, so you can see what you're trying to image, you need to capture photons and do computations on that data and put it on the screen very quickly. The camera is not fast enough, the cell phone is not fast enough to do that all at once. So what the cell phone actually does is it scans, and it's going to scan line by line. So it's going to record the data where this green line is, and it's going to start displaying it as it scans the next line. And it's going to scan and display, and it's going to go like this. And just like the DSLR, the faster this happens, the less light your camera records. If you have a slow shutter speed, it's going to record light for a longer period of time on each line of that sensor, and you're going to get a brighter image. So what can you do with shutter speed that sets it apart from the other ways of controlling how much light enters your camera? Well, we're trying to make observations during this program, right, in imaging science. So let me show you what you can do. So for example, on the left side of the screen, these two images here were taken with a fast shutter speed, or in other words, a very short shutter speed, maybe around 1/1000th of a second. This means it freezes the motion. Because the picture was taken very quickly, you can freeze what's happening. So as this car moves across the screen here, I'm able to capture it so it looks like it's staying still. Same thing with this, this carnival ride in the picture on the bottom. But you'll note is with this fast shutter speed, I don't capture much light. So if you look at this building next to the ride here, it's very dark. So I may want to lengthen that shutter speed. So I may want to have it open for a longer period of time. And what that can do is it'll blur your image, but it'll show motion because the camera is going to be collecting photons while something is moving. So in the first example, maybe I want to show the motion of the car. So this is a long shutter speed. This is probably around a 1/10 of a second. And as the car moves across, it blurs. So you're capturing the car in lots of different positions, but it shows the path really well. Same thing with the carnival ride on the bottom. Now we can see the motion. From the first one, you may not know that this is a spinning ride. But in the second one, it's very clear because it's blurred out in this circle that this is spinning very quickly. You'll also notice that this building to the side is much brighter. And again, that's because we've allowed the camera to capture more photons when that shutter is open. The next setting that we're going to talk about is aperture. Now, aperture is the one setting that you cannot control on a cell phone. But on most other cameras, you do have control of this feature. The aperture is essentially the hole that the light can travel through in your camera. So in your lens, you usually have these kind of circles, and this is going to open up different amounts depending on your aperture setting. The wider your aperture is, like the one on the left, we're going to let more photons into your camera. And the one on the right here has a much smaller hole, so that's going to block most of the photons. So this is going to be a much darker image with the smaller aperture. Let's see how the aperture works. So besides controlling how much light comes in the camera, why would we use aperture to control brightness? Well, just like shutter speed controlled how you can show movement or freeze movement in an image, aperture has another ability where it allows you to control what's called the depth of field. This is how much is in focus when you take your picture. As you can see in these pictures below, with a wide aperture, so a very open aperture here, only a small amount of our picture is actually in focus. As we close down this aperture, as we make the hole smaller, more and more of the picture is going to be in focus. And this is going to let us do things such as call attention to certain parts of the image. If you can control how much of it is in focus, you can highlight something by putting it in focus and blurring out the things that maybe aren't as important to the image. Or if you want to show, if everything in the image is important for what you're trying to show, then you might want to use a smaller aperture and keep everything in focus. Aperture is measured in what is called f-stops, or f-numbers. So the f-numbers work by going lower numbers. So f1.8, for example, a low number, is a wide aperture. The higher the number, such as f32, is a smaller aperture. The reason that these numbers seem a little bit reversed to what you may think they should be is that they represent a ratio between the focal length of a lens, essentially how zoomed in the lens is, and how wide the lens is. So now let's take a quick look at how the aperture works in terms of changing the depth of field. So let's say we want to take a picture of this puppy here. And so light is going to come from the puppy and go to the sensor. In between that, the subject and the camera and the sensor is the lens. So what the lens is going to do is take parallel lines of light that come into the camera, and it's going to focus them onto what's called a focal point. So all of these lines of light are going to cross at a certain point. But the lens can only do this, it'll only focus light to the same point if it comes in parallel to itself. If we have light, let's say, that comes in at a different angle, this light is not going to be bent to the exact same point. The aperture is going to basically control what angle the light can enter the camera. When light doesn't come in parallel to itself, it's no longer focusing at the same point, and it's going to be blurry. So we'll remove the lens just to make this a little bit simpler, and we'll look at the aperture. So the aperture, as we said, is just the hole that the light is going to enter the camera through. And so when we have a small aperture like this, light is coming from our image from all different directions here. But with a small aperture, only light that is parallel or at a very small angle is able to pass through and get to the sensor. All this other light that's coming in from different angles is going to get blocked by that aperture. So since all the light coming through is parallel, it's all going to get focused to the same spot, and no matter where it came from in our image here, it's all going to come into the camera at the same focus. So we have an image where it has high depth of field. Everything is in focus. Now let's say instead we have a very wide aperture. When we have a wide aperture, the light that's going to come into the camera, it doesn't have to be parallel. Some of it's going to be parallel, but we're also going to allow light in that's coming from all sorts of different angles. Because we're allowing that light into the camera, it's not going to focus the same way as it passes through the lens. Your camera's only going to be able to focus on some of this light, basically light that's only come from a certain area of this photo. So let's say we want to focus on his nose, then all of the light that's coming in a straight line from his nose, that's going to be able to be focused. but light coming back here from his ear, that's coming in at a slightly different angle. It's still now reaching the sensor because we have a wide aperture, but it's not going to be in focus. It's going to be a bit blurry, and that's how we're going to get that blurry background or foreground or whatever you're trying to do in your photo. The third and final setting that we're going to talk about in our camera is what's called ISO. ISO used to be ISO, standing for International Standards Organization, used to be a standard measurement of what was called film speed. Essentially, how sensitive was the film to light? In today's cameras, whether it's a cell phone or DSLR or any digital camera, it's going to measure the sensitivity of the sensor, and it's no longer standardized. So different ISO numbers are going to match up to different effects, and we'll talk a little bit about that in a minute. But basically, the lower the ISO, so let's say we have an ISO of 100. So if we have an ISO of 100, this is going to require a lot more photons in order to get the same brightness of image than if you took a picture at 1000 ISO. So you need fewer photons to get the same brightness in an image, because the sensor it's more sensitive to that light, or it's amplifying the light more with the higher ISO. Now this sounds great. Well, why don't I just control how bright my image is using ISO? And just like shutter speed and aperture, ISO has its own effects on an image. So if we take a look at these images, these are 4 images taken with all the same settings except for different ISOs. If I put on the labels, you'll see the upper left corner is at 100. So this is a very dark image because there was only a few photons coming to the camera, a few meaning millions. When we're talking about photons, we're talking about millions, billions of photons entering the camera. But this had a relatively small number of photons entering the camera, so it's not a very bright image. If we boost the sensitivity, if we raise the ISO to, let's say, 1000, you can see the image is becoming brighter. It actually captured the same number of photons in both images because we kept the aperture the same, the shutter the same. So you're starting to see more detail. We keep going. Here's ISO 5000. It's even brighter. We can see a lot more detail in the image, but you're also starting to see some graininess in the image. And this is really pronounced in this image at ISO 10,000. You can see a lot of graininess, and this is called noise. Basically what this is that we're getting most of our photons from the image from the same points in space, but there are some random photons that are entering the camera. And because we're capturing very little light, remember that at ISO 100 for this image, we really can't see much. So if we have a stray photon, a random photon, come into our camera, we're going to detect that because we don't have all the other photons from our image, from this fireplace here, to cancel that out. Another way to say that is we have a very low signal-to-noise ratio. So there's not much signal, meaning light from the subject that we want to take a picture of. So the noise, the randomness, is very easy to see. Where if you use a low ISO, and if you have a lot of light coming in, the signal-to-noise ratio is very high. So you have a lot of photons from your subject. So the relatively few photons that are coming in from random sources aren't going to appear. So to wrap up, let's go back to our exposure triangle. And there are 3 settings that we can control on a cell phone too. And they're all related to each other. They all control how much light comes into your image. So how do you decide what you're going to do? So it depends on what you're trying to show in your photo. If the motion or the amount of motion in your image is really important, whether you want to freeze your image, you're going to want to pick a shutter speed that gives you the effect you want, and then adjust the other 2, ISO and aperture, to get the brightness that you need. If the important part of your photo is the depth of field, so what's in focus, what's not in focus, then you're going to set your aperture first and then adjust the other two to give you the correct exposure for your image. Now this triangle is great, and it lets you do all sorts of really cool things, but there's one thing that's really easy to forget in photography, even though we talk about it all the time, and that's light. Right? Everything we're talking about is how much light is entering your camera. And if you're trying to take a photo and you're not able to get the effect you want, maybe you want a high depth of field and you want a fast shutter speed, but your image is getting very grainy because you have to use a high ISO, well, what can you do? Well, how about get more light, right? So you can always control the light, or in most cases, control the light that's around you. So using a flashlight, ceiling lights, the light from the window, cell phone light, laser pointer, flash, whatever you have around you, use light to compensate for what you want to do with this exposure triangle. Now let's try a couple of examples and just see what we would do for camera settings. Now, camera settings are going to vary for every camera that you try to use. So these are just going to be rough estimates. So for example, I want to take a picture of this bird here. So this bird, it's flying in the air, so it's moving. So what am I going to prioritize? So movement's involved, so I'm going to pick, in this case, shutter speed. So what I want to use for this photo is a short shutter speed. Or fast shutter speed. So I'm going to do a short shutter speed, and that's going to mean my image is going to be dark. So I need to figure out, well, what are the other things I can adjust? Well, I don't really care about the background detail. I'm taking this picture to capture the bird. So if I don't need the background to be in focus, I can use a wide aperture or a low f-stop number. And that will blur out the background, but it'll also give me more light. And then what that leaves me with is the ISO. And I can adjust that to get the exposure I need based on how much sunlight there is, if there's cloud, or a bunch of other factors with the light. So again, for this image, short shutter speed to capture the motion, a wide aperture to compensate for that lack of light, and then I adjusted the ISO to get the image that I wanted. So let's look at a second example. In this example, I have a close-up image of a dime. Now, as you move closer to your subject, one thing that you're going to discover is it is harder to get everything in focus. Your depth of field decreases as you move closer to the image, and that has to do with the angle that the light's entering your camera. In our next tutorial, we're going to specifically talk about close-up imaging or macro photography. But for now, if I want to take a picture with the entire dime in focus, well, which setting am I going to focus on? Well, I'm worried about depth of field, so it's going to be aperture. So what I want to use here is a small aperture in order to get that depth of field, or a high f-stop number. If I'm going to have a small aperture, that means that my image is going to be very dark because it's not letting light in. So that maybe then I'm going to choose a long shutter speed in order to compensate for that. And then again, I'm going to adjust the ISO in order to get the exposure I need. So in this image, depth of field was the priority, so I chose the aperture and then adjusted the other settings accordingly. Thank you for joining us for this tutorial in our Imaging Science series with the MIT Museum and Koch Institute. We'd love to see your stunning science photos. If you'd like to share them with us, you can share them on Facebook, Twitter, and Instagram, and use the hashtag MITMImagingScience to share those with us. At the end of this program, so on June 20th, we'll be holding a webinar to look at what makes a great science photo, and so submissions have a chance to be featured during that webinar. For more information on the imaging science program, other tutorials and other information and resources, please visit the MIT Museum website at the link below, and you will find a list of our other resources as part of the imaging science program.